Hello everyone. In this session, we will discuss about MySQL storage engines. MySQL supports different types of storage engines. So let's see what are the storage engines available in the MySQL database. So first one is InnoDB storage engine. Second one is MyISAM storage engine. Third one is memory. Fourth one is CSV. Fifth one is merge storage engine. Sixth one is archive storage engine. Seventh one is federated storage engine. The eighth one is black hole storage engine. And the last one is example storage engine. The storage engine name is example. So here we have two types of storage engine. The MySQL supports transactional storage engine and non-transactional storage engine. Transactional, non-transactional. So from these, InnoDB comes under transactional storage engine. MyISAM supports non-transactional storage engine. So transaction is nothing but this is mostly used for banking applications or any finance applications where you need consistency and integrity of the data. We use transactional storage engines. So let's go one after the other in detail about the storage engines. So first let's discuss about InnoDB storage engine. InnoDB storage engine is a transactional storage engine. Transaction storage engine. It supports transactional applications. So and most of the business in the real world, 95 to 97% use InnoDB storage engine. And it supports acid. It is acid compliant because it support as it is a transactional storage engine. It supports acid properties. You see, it is acid compliant. You can say acid compliant is nothing but it supports. We have RDBMS acid properties, right? Atomicity, consistency, isolation, and durability. These are the these are the compliance it will support for a consistent database management. And it supports row level locking. Supports row level locking. Row level locking, and also multi-version concurrency control. It also supports multi-version concurrency control. Multi-concurrency control is nothing but running multiple queries in parallelly on a single table or on a single object. We call it as concurrency control. It supports it concurrency. And in InnoDB storage engine, the default storage area for data dictionary is it stores in the system table space. So in system table space, it will store the data. The default storage area is data dictionary table. Data dictionary it stores in the system table space. And also it also creates it also contains tables and index data in the data system table space. If tables are created in system table space rather than file per table or general table space. So by default, a single system table space data file and named it contains by default it contains a single system table space data file that is with the name ib data1. IB data1. So this is a default data file. It will be in the data file in the system table space in the data directory. It is created in the data directory. So the size and the number of system table space data files is we can define this number of data files in the system table space and the size of this data file using a parameter called InnoDB underscore data underscore file underscore path startup option. There is a parameter called InnoDB underscore data underscore file underscore path. So this is the parameter where we define the size and number of the data files for the system default system table space. Yeah, this is the option. So we can also even give define auto extend parameter for this data file. So that is let's example InnoDB. How to define this parameter? We can give example data underscore file underscore path IP data1 colon 10 MB then colon auto extend. So this is how you have to define the parameter this auto extend and data file path. So when the auto extend when we specify this auto extend attribute in the data file path, the data file automatically increases its size by whatever the size we have mentioned, right? Here in this example we have mentioned 10 MB, so it will automatically increase by 10 MB as the space whenever the space is required. So and also there is another variable another parameter called InnoDB underscore auto extend underscore increment variable. So that also defines the increment size. And also in this InnoDB storage engine architecture, it uses file per table architecture. So for each and every table, it creates one file. So it will create one file for each and every table. So here in the same table, it will store data, it will store indexes, and also data dictionary. It will store data, index, and data dictionary of the of a table in a single file. So so we call this as file per table. My InnoDB supports file per table. So this one. So what are the advantages of file per table? File per table advantages. So when you use file per table when you use this file per table concept, so what it does is whenever you delete or truncate any table, it will release all the space occupied by the table by that file, and that can be used for any other new upcoming or newly coming InnoDB data. So and also in this storage with this file per table concept, the truncate operation will be if you perform any truncate table operation, it will give better performance and it will be faster. And when you try when in case of any backup or recover of this any tables, it will be faster because it will be very easy to recover or restore any table using this file per table, because this table, as it is using file per table architecture, it doesn't it will not interrupt any other InnoDB tables while doing restore or recovery of these tables. And also the table the restore and recovery performance will be faster when you use file per table concept. And tables stored in this table space data files can save time and improve chances of recovering the data from the backups or backups when these tables are corrupted. So these are the few of the advantages of InnoDB storage engine file per table concept. Now tables in the shared table space are limited by size of 64 terabyte table space limit. So each file per table space has a 64 terabyte size limit. So which means it can grow, which will provide plenty of space for each table to grow in size. So each table can grow till 64 terabyte of space when you use file per table for this. So as we have advantages, we also have disadvantages for this file per table. So when you use file per table spaces, each table may have unused table space that can be that can be only utilized by the rows of the same table, because it cannot be utilized by other tables. So you will be having lot of space, lot of unused space, which is which has been reserved for only that table, which can lead to space wastage if we don't use properly. Suppose if you have 10 GB of space, suppose if you have 20 GB of space but you are using only 15 GB, so and the remaining 5 GB is allocated for the same table, but we don't have, but we have only 15 GB of data, so we have here 5 GB of extra space which cannot be used by another tables. So this has to be used by the same table. So that is where we cannot, storage space will be getting wasted. So and again also when we perform fsync operations for replication of file system at storage level. So when you perform these operations on multiple file per table data files, instead of single data file, fsync operations are performed at file level. Write operations for these multiple tables cannot be combined, so which can result in higher total number of fsync operations, because you have to do this with individual file level. So we have to it can result in a higher total number of fsync operations. And also MySQL process will be there for each and every operation. So that must keep a file handle open for each file per table space, which may impact performance if you have more tables in file per table spaces. And in Linux, whenever we do any operation, it will open the file using file descriptors. We have file descriptors in Linux which will open the file when you read data from the storage. So and when each table we need more number of file descriptors when each table has its own data file, because if you are fetching data from 3 to 4 tables, it has to open 3 to 4 data files. So that is the reason where you need one file descriptor for each and every table. So these are the disadvantages of file per table in the InnoDB storage engine. And you have some limits for InnoDB file per table. You have the maximum in we discussed right earlier. We have the buffer. When you have this buffer in the previous architecture we discussed, buffer is divided into pages. So these pages we have limits. So using depending upon this page size, you can have the maximum table space size of the this InnoDB file per table. So now we discussed right that each table data file can extend up to 64 terabytes. So that depends upon the page size. So here we can see what are the sizes. InnoDB page size and maximum table space limit. So we have page sizes 4K, and we have 8K, 16K, 32K, and then 64 KB. So these are all the page sizes. So if you have 4K page size, it will support maximum size until 16 terabyte. So then if you have 8 KB, it will support until maximum file size is 32 TB. So if you have 16 KB, it is 64 TB. If you have 32, right, it is 128 TB. If you are using 64 KB, it is 256 terabyte. So these are the maximum file size supported depending upon the page size. So when you are defining this InnoDB page size, you should be careful that how long your data can be grown, or how long the maximum size limit you want to use. These are all the this is all about InnoDB storage engine. So now let's go with MyISAM storage engine. So MyISAM is the storage engine. So by default, until MySQL 5.5 version, 5.5 version, MyISAM is the default storage engine. So from after 5.5 and later versions like 5.5, after 5.5 and later 8.0 version, the default storage engine is InnoDB storage engine. So for MyISAM, this MyISAM is the non-transactional storage engine, and it is very fast storage engine, because it doesn't follow any ACID properties. So it doesn't need to check any ACID properties. This is mostly used in data warehouse applications or any social media platforms. Platforms, and also it will provide table level locking. So table level locking is nothing but suppose if someone is inserting or updating any records, it will lock the table until that operation is complete. And it is used mostly in the web, social media or any web applications or data warehousing. And also InnoDB stores data in the InnoDB stores user data in the clustered indexes to reduce IO operations for common queries based on the primary keys. So there is a limit for in this MyISAM, right? It will maintain 3 files per each table. MyISAM maintains 3 files per each table. So one is for data, one is for index, one is for dictionary, data dictionary, and this is used for web and data warehouse. Data warehouse applications it is used. So here we have limits. So the maximum number of indexes each MyISAM table can have is will support is 64. So you can have 64 indexes for each table in the MyISAM each MyISAM table, and in each table MyISAM supports MyISAM tables can create. We can create 16. We can create indexes on 16 columns per each table in MyISAM for MyISAM tables. And MyISAM supports concurrent insert, because concurrent inserts. So we can in MyISAM table we can do parallel. Concurrent is nothing but parallel. Parallelly we can insert parallel inserts in a same table, MyISAM table. And also in MyISAM supports creating indexes on blob and text columns. So blob and text columns we can create indexes, and also it also supports creating indexes on null values in columns with null values. So it supports creating indexes on blob and text columns. Also it will also allow null values in the creating indexes in the columns. So and also MyISAM tables, we can repair these MyISAM tables with a command called repair table. So MyISAM table with repair table. When SQLD is not running, you can also check and repair a table with the MyISAM check command. So there is a command called MyISAM check. That command we can use, and we can create the we can do the repair of a table. So and also here MyISAM in MyISAM storage engine, it will permit data and index files to grow up to 256 storage 256 terabyte by default. So by default you can go in MyISAM the table size is 256 terabyte. It will allow to the file to grow till the default limit is 256 terabyte, and you can increase it till 65,536 terabyte. The maximum cap is 65,536 terabyte. Because this is a data warehouse, it is mostly supports data warehouse, right? So data will be coming and dumping into this data. So that is the reason it supports more storage, more amount of data. So now let's this is all about MyISAM storage engine. So now let's go to the other storage engine, which is memory. Memory is also one of the storage engine. Storage engine in which we can create tables in the memory. It is a very fast storage engine. Memory is very fast storage engine because you all know, right? Memory is very faster than disk I/O. So then this is one. So this is mostly for supported for reporting applications because only select operations we can do, which will be very faster in the memory. So and this does not support transactional applications. It is ideal for only creating temporary tables for quick lookups because we cannot. It does not. It supports only for reporting or any temporary table creations. We use this storage engine, and this is about. And when you restart the database, right? MySQL database, the data in the memory will be lost, and again after when you restart this storage engine, it will be the data in the memory will be lost. So this is about memory storage engine. And coming to the next, CSV storage engine. This storage engine, it is a storage engine in which the data is stored in the form of CSV files. It stores in the form of CSV files. So we call it as Excel files. So this storage engine gives us feasibility to store the data in the Excel files, and we can integrate this storage engine to the other applications for analyzing. And next, coming to the merge storage engine. This merge storage engine operates on underlying MyISAM tables. So merge table in this storage engine, merge tables help manage large volumes of data more easily. It logically groups some identical MyISAM tables and reference them as one object. So this is more suitable for data warehouse applications and data warehouse environments. And then coming to the archive storage engine. So archive storage engine, it is used for high speed compressing the data. In the storage engine, it will optimize it is optimized for high speed inserting. It compresses data as it is. Whenever the data is inserted, it compresses the data because the name itself suggests that it is an archive storage, which is nothing but it is only for storing the historical large amount of it is for storing and retrieving large amount of data or any historical or archive data. So for cost saving purpose, we use archive storage. So this is for storing historical data and archive data. So next, coming to the black hole storage engine. So it is for retrievals. The functionality it is used for using the distributed database design, where data is automatically replicated but not stored locally. So this is for replication storage engine. It is used in distributed databases where we have to replicate the data automatically, and it doesn't store the data in the local storage. So and the storage can also be used to perform performance test or any other testing applications. So next, coming to the federated storage engine. So this offers ability to separate MySQL servers to create a logical database from physical servers. So in this storage engine, queries on the local servers are automatically executed on remote tables. And no data is stored in the local in this storage engine. We don't store any data in the local tables, but it is good for distribute. It is also good for distributed databases environments. So these are all about storage engines, and we mostly most of the market is using in the real world using only MyISAM table, MyISAM storage engine and InnoDB storage engine. So 95 to 97% this uh, InnoDB storage engine is used, and other 3 to 5% they use MyISAM storage engine, and maybe there are lot of many very rare scenarios where we use another remaining storage engines. So this is all about storage engines.